Welcome to our second lesson about an introduction to ROS2. Today we're going to build our first robot together. As you can see, I build up a very simple robot. It is movable and controllable using some sliders. We say in this case, the robot has some degrees of freedom. Please note that every part has a frame attached to it. This frame is a very important concept, which makes our robot movable. Before starting, I created every single part using FreeCAD, but you can use any other tool that you want. In this case, we have 4 parts: the base, the body, the arm, and also the manipulator. In total, we have 4 parts. Remember to take a look to the XML specification for building robots, where you can find all information you need for implementing your URDF file. An interesting thing to know is that scrolling down into documentation, you can see that there is a possibility to import and use a mesh file instead of creating your parts from ROS. Just fire your preferred CAD program, create one part of the robot and export it as a COLLADA file. Let's generate our package inside our source directory. I call it UDO. So we open now our package XML file in order to edit it. For instance, you want to edit the version and a description of our package. By the way, I can even change the license for this package. Then we have the second file that we have to edit, setup.py. Version, description, license, and maintainer are all information you can edit. In this case, I edit only the description and the license for this package. Once done, save the file. We are going to create a subfolder, which is called URDF. In this folder, we store all the parts as mesh files of our robot. So I move all the mesh files into that folder. Moving the mesh in there, I know which is the path to every single file. So we need now to create an empty file where with the name URDF model URDF and open it for editing. The first line is mandatory. You can copy it in any project. Now we start implementing our robot by opening a tag. Remember to close any tag using a backslash. The robot description goes between the tags robot. Our first part is the base, which is attached to the ground. Precisely, this face should be connected to the ground. First of all, we need to create the world link, which represents our fixed world. This is just an imaginary frame which is not visible, but this is mandatory for referencing the robot position in our world. Now we can introduce our first real link, the base link. Remember to open a new tag, Visual. Inside it we put the geometry, that in our case will be the mesh. Remember the 3 slashes followed by the path to your COLLADA file for the first link or part. So we then close the geometry tag and now we define an origin for this part, which will be 0, 0, 0. Those values fits in almost every robot configuration. Last but not least, close the visual tag and the link tag as well. We define the first two links, the world link and the base link. Those parts have been created using a CAD program and now they must be joined together. Let's call this joint ODM. Let's define it as of type fixed because we want to connect the lower part of the robot with the world statically. We need to define the parent link, world, and the child link, base. Basically, we are telling ROS that we want weld those bodies together, no rotation or movement between them. Remember that the joint is always the connection element between two different links. But even if there are 6 different joints available, the last 2 joints, floating and planar, have been deprecated in ROS, so we cannot use them. We import now the body part and we define a new joint for connecting the body part to the base part. The first part can be called body, for instance. Again, we have to define a visual tag. Inside it, the visual tag followed by the geometry tag. Inside the geometry tag, we import the mesh file for the body part. Again, even in this case, we have to define the path to our file location. Please note that now we have to combine those parts together. We have to join the base and the body part, so we define now a new joint, which allows rotation along one axis. The type will be continuous because we want a continuous rotation between the body and base part. The parent link will be base and the child link will be body. Pay attention now because we have to define axis of rotation. That means XYZ001. Axis 1, because if you take a look to our robot, you can see that the body part, the blue part, is rotating around the z-axis belonging to the part, the base link. So since it's rotating about around the blue axis, we have defined a rotation around that axis. For this reason, we put 001, 0 for the x-axis, 0 for the y-axis, and 1 for the z-axis. Then we have to define the origin of our joint as well. In this case, we will put the displacement or the offset between the two frames. Again, take a look to our robot. This distance was already measured by me using my CAD program when creating the robot. In this particular case is the distance 0.2. In other words, the second joint is 0.2 meters above the other joint and no displacement on the x and y axis. I quickly implemented all the other links so we can move forward. The next part of the robot is the arm, then the manipulator, and then the relative joints. So the first joint is the body rotation, which is a continuous joint around the base part. This is an infinite rotation, with no boundaries around the z-axis and a displacement of 0.2 meters. Then we have the second part in the arm. Note the two displacements. We define the arm rotation as a continuous one around the y-axis. For this reason, we need to write 0, 1, 0. Carefully take a look to the green axis. This represents the y-axis around which the arm should rotate. Plus we have some displacements between the two frames. So this is the horizontal displacement, and then we have this vertical displacement. At the very end we have the manipulator, which translate along the y-axis. Since this is a prismatic joint, we need to carefully take a look into the ROS documentation about URDF XML definitions. The prismatic joint, as well as the revolute joint, requires the definition of the range of movement. We define now the origin for this part. Last but not least, we define the rotation for this part. Note that the frame for the manipulator is rotated around the y-axis. For this reason, those axes are not looking in the same direction. According to the XML documentation, we have to define the joint limits as well. This is a mandatory step. We cannot neglect it, otherwise our file is not parsed correctly. In the fields effort and velocity you can just put any value you want. They are seldom used in ROS. On the other side, the lower and the upper limit are very important, and they are defined as the minimum and the maximum boundary, hence the range in which the manipulator can move. Take a look into the documentation. For the prismatic joint, there are 4 different attributes: lower, upper, effort, and velocity fields. Our first URDF file is now complete. In order to visualize it, I'm going to use the URDF tutorial, which is a package of ROS, which must be installed separately into your system. In my case is already installed, so all I need to do is to type ROS2 launch URDF tutorial display launch model and then the path to the URDF file. Let's rename the file in robot model URDF by chaining the file name. Press enter so we can start. At the beginning, it is normal to get such errors because our VIZ does not know that we have to select the right frame first, which is in our case our dummy frame, world. Here is the newly created robot in our environment. It's built according to our build instruction in the URDF file. We can move it as expected around the first axis, the second axis, and the manipulator can be translated around this axis as well. Yeah, this is all for this lesson. Thank you very much for your attention. In the next lesson, we are going to automate the movement of this robot. See you soon.